We always start this type of question by sketching the region to have a clear idea of what we're doing here, and what type of volume, what type of area we're dealing with. So in this case, I'll put the XY axis right there for me. XY plane. Y equal to minus or e to the minus x. That is the regular exponential function, but reflected across the y-axis, so it's going down instead of going up. Y equal to 0. So this top one is y equal to e to the minus x. This is y equal to 0, the x-axis. X equals to 0 is this guy, and then x equals ln 4, some number in there. So this is an area that we have that's bounded here. We're told as well, so that's the first part of the question, sketch the region. We're good on that. Now we're going to find the volume of the solid that's generated when this region is rotated around the x-axis. So we're rotating this guy around, and we're getting this, almost looks like a cone thing, but it really isn't. This volume. How do we find the volume of this thing? We use the slicing method, but a special case of the slicing method, we are integrating the areas of the cross sections from 0 to ln 4, right? From 0 to ln 4. But the cross sections are circles. Right? If you were to cut this right in the middle, that would give you a circle, right? So your cut is a circle, like the format of your cut. So this area right here is going to be the area of a circle, pi r squared, and that's what characterizes the disk method or the disks method. Each cross section has the format of a circle. Could be something else, but then it wouldn't be the disks method anymore. Okay, so with this disks method, you're going to integrate this area. What is the radius on each of those circles? Look at that purple circle in the middle right there. What's the center? It is right here on the x-axis. This is the center right there. And the radius is the distance from the center to one of its points. It is this height right there. It is y. Yeah. For each x, we have a different circle, a different radius. So that is y. This is 0 ln 4 pi y squared dx, because y is the radius. Y is the distance from the center to the point on the circle. Now I know an expression for y in terms of x. I can't integrate this the way it is because this is y and I'm integrating with respect to x. So I got to change it to x first, and then I can integrate it fine. And that's not that bad. As the integral 0 ln 4 pi e to the minus x squared dx. So that is the integral 0 ln 4 pi e to the minus 2x dx. To resolve this, I'm going to use a substitution rule. U equal to minus 2x, du is minus 2 dx. So minus 1/2 du is dx. So that allows me to replace this dx right here with the minus 1/2 du. So taking this minus 1/2 and combining with the pi, that will give me a minus pi over 2 that I'll bring out of the integral. It's e to the u du. In fact, now that I make that change, these are no longer the limits of integration because I'm no longer integrating with x. I'm integrating with u. Okay? So I have two options. One thing I like to do is to change those guys into a and b, integrate that in terms of u, and then go back to x to do it, to plug in the values, which means I can go back into ln and 0, ln 4 and 0. But one thing that's also possible to be done would be to just look at this expression. That's something I chose. I just use sub. And note that when x equals 0, u is minus 2 times 0, so it's also 0. So this guy at the bottom is 0. And when x equal to ln 4, u equal to minus 2 times ln 4, because that's x. So that is the top limit of integration. So we can just proceed with this integral without having to go back to x later, since we're only interested in a number. Now the antiderivative of e to the u, in terms of u is e to the u, that's an exponential function. It's its own derivative, so it's also its own antiderivative. And we plug that in from 0 to minus 2 ln 4. So how do we find what the answer to this is? It's minus pi over 2, open parentheses, e to the minus 2 ln 4 minus e to the 0th. So that is minus pi over 2. Okay, so when I plug that in, I can reorganize this as e to the ln 4 minus 2. And then e to the 0th is just 1. So here note that if I were to take the power of a power, all I can do, one thing I can do is multiply 2 powers. And that takes me back to where I was. So that shows this splitting up here is correct. And therefore I can write minus pi over 2 times 4 to the negative 2, which is much easier to see. That is 1 over 16 minus 1. I didn't manage my space very well here. I had a lot of space, but I didn't use it well. This last step for me will be to look at this 1 over 16 minus 1, and note that this is minus pi over 2 times minus 15 over 16, which then shows this is 15 pi over 32. That is the answer here. We're looking for an exact answer in this question. We were never told to approximate, so this is what we have.